remember, what we're going to be doing today is we're going to continue talking about conic sections. All right, there are 4 different conic sections. There's parabolas, circles, ellipses, and hyperbolas. And the equations have different forms. One of the things that you are responsible for is looking at the equation and determining which kind of conic section is there. So the first thing you have to know is that for a parabola, you have one that's squared, one variable is squared, the other one is not. Now, the one that's squared will have 2 directions, and so it's going to form the parabola. So if it's y, you're going to have y coming down, y going up, right? And it will have an axis along the single or the x-axis. So if the x-axis goes sideways, the y would be this way and this way. If the x is squared and the y is linear, then it's going to be along the y-axis, which is our normal parabola that opens 1, 2 on the x's. So because the x is squared, there'll be 2 directions, right? And that tells you which way the parabola opens. And then positive or negative will be positive or negative on the single linear axis. All right, now a circle doesn't have 1 square, it has 2 squares. So if you'll notice, here's x squared and y squared. All right, because they are both the same, it's going to produce a circle. If they are different, like 4 and 9, then they're going to produce an ellipse that's going to be elongated circle. Okay? So that's what you look for in the equation. Both of them squared, both of the coefficients the same. Now, if both of these were, we'll say 5, then you could divide by 5 and this number would change to some other value for the r squared. But in order to have this as r squared, you have to have 1x squared and 1y squared. So sometimes you have a little extra math to do. Now, the ellipse and the hyperbola are also squares. Right? Both of them have differing x's and y's as far as the square. You notice this has 4 and this has 9. Because they're not the same, it can't be a circle. Right? Now, this has 25 and negative 1. Because they're not the same, it can't be a circle. Now, how do you tell the difference between the ellipse and the hyperbola? The ellipse, both of these are positive. In the hyperbola, one's positive and one's negative. All right, so when you look at the equations, that's what you've got to be able to do. We're going to practice that today. Okay? Now, what we did last week, and I'm going to go through that one more time with my brand new markers. Hopefully they work. If I give you x minus 1 squared over 4, and then y minus 4 squared over 25 equals 1. All right, this is either an ellipse or a hyperbola. All right, and what we first have to do is figure out where's the center. All right, the center of the circle is at the opposite of those numbers. So the center of the circle is going to be at 1, 4. All right, 1, 4, that's that location. Now, for hyperbolas and ellipses, we have to find the box. All right, the length of the box is the square root of these numbers. Actually, let me take it back. The distance from the center is the square root, so the length likes to be 2 of them, right? So what's the square root of this? 2. So in the x direction, we're going 2 and put a dot, going 2 and put a dot. Okay? For this, the square root is 5. So we're going 5, 1, 2, 3, 4, 5 and put a dot. 1, 2, 3, 4, 5 and put a dot. Now this box will contain the ellipse if this is positive, plus in between. The box diagonals will form the asymptotes if this is negative and it's a hyperbola. hyperbola. Hyperbole is English. Okay? All right. So if I draw the diagonals, this is going to come down here, and this is going to come down here. That's going to go up there, and that's going to go up there. Now, I want to be, the way this is for hyperbola, I need to be along the x-axis, so I'm going to use this dot and this dot. And I'm going to come and draw these like asymptotes. And I have just done that when it's negative in between. What would happen if the x and the y were switched? If both of these fractions were switched, then I'd use these 2 points, and I would have come down like this and up like that because the y was first for the hyperbola. Okay, now, if it's a plus, after you draw the box, you just draw the ellipse. So those 2 things go together as far as your understanding is concerned. Okay? The question is going to be, if you're given the equation, can you identify it as an ellipse or a hyperbola? Right? The answer is, well, you have to look at the squares. They both have to be squared. If one is positive and one is negative, then you're doing the outside because you have the hyperbola. If they're both positive, then you're doing the inside. You're doing the ellipse. Okay? Question? All right. Okay. Now, if you'll get your handout practice, we're going to do the skills that are part of this chapter. All right. Oh, now this is not going to be big enough, is it? Let's see how I can. Let me try to take this higher. Is that better? Is that a little easier to see? Okay. All right. So now the first part of this page, all we're going to do is look at the equation and try to determine what kind of conic section it is. Okay. What do you notice about number 1? They're both squared. Okay. What about the coefficients? They're both 1, right? So therefore, this is a circle, right? So it's a circle. What's the radius of the circle? No? 15. Square root of 30, not 15. It's somewhere between 5 and 6. Yeah. Okay? Because it's the radius, because this is radius squared, so we have to take the square root of it. Okay? All right, now, number 2, what do you see?
Both squared.
Both squared, both the same. Correct? Same coefficients. So this is also a circle. What's the radius? 6. All right? Because that's a perfect square. Okay? Now. All right? Number 3. What do you see? Both are squared, but the coefficients are the same. Now, originally what this looked like was 16x squared plus 9y squared equals 36. That's what it used to look like. And when it was divided by no, it's not 36, I'm sorry. 144. When it was divided by 144, the 9 that was here was the leftover factor, and so it ended up down here. The 16 that was 16 times 9 that made up this ended up down here. Okay, that's just for your information, is that these coefficients trade places if you're given it like this. Because we have to get a 1 on the end. So when I divide by 144, these coefficients trade places. Now, what kind of section is this? It's an ellipse. Why? Because they are both squared and the coefficients are different. This happens to be 1 over 9 and 1 over 16. Okay? Now, where's the center of that circle or ellipse? It's the number up here. What's added to the x? 0. What's added to the y? 0. So the center is at 0, 0. Okay? Now, what's the length from the center in the x direction? Square root of this. 3. So it's 3 here and 3 here. What about this way on the y?
4.
4 here and 4 here. So what is the length of the major axis? 4 plus 4 is 8, or 2 times 4 is 8. Okay. What's the length of the minor axis? 6, right? 3 plus 3. And so if I were to draw the rectangle, I would then draw my ellipse inside. Now, had this been a minus sign, I would have done the rectangle and then drawn the draw the diagonals, and I would have used the x dots here and here to make my hyperbola. Okay. On number 4. Okay. All right. Question? All right. Good. Next one. What do you see in 4? Only one of them squared, so what do we have? Starts with a P. Parabola. And which way does it open? It opens along the x. And the y squared is going to be like that. Alright? Had one or the other been negative, and you ended up with the negative sign, it would have opened in the negative direction if the y squared was negative and the x was positive. Okay? And again, because there's no other numbers, right? The center point is 0, 0. Right? The vertex of that parabola is 0, 0. Okay, now number 5. What do you see? What do you see? I see a y that is squared and an x that is not. So what kind of section? Parabola. It's a parabola, right? Okay, now, which way does it open? It opens along the x. All right, now, where is the vertex? Now, this is the y value. The y value will be negative 4. And the x value, this is the opposite. This is the same. Because had this been over here with the x, and with the opposite of positive 2 is negative 2. So now, the trick with the higher level parabolas, this is not a function because of the way it sets up, is that remember that the x goes with the x and the y goes with the y. So the y has to have the negative 4. A lot of times what would happen is we take what's inside the parentheses and make that the x value. Okay, you've got to be careful with parabolas now because you're not using just functions. You can use the parabola going in either direction. So we're going to go here. We're going to go at negative 2, negative 4. We're going to have our vertex, and it's going to open to the positive x direction. So it's going to go like this and open that way. All right, question? All right, good. Okay, now number 6. What do you see?
Both squared.
Both squared. Okay, so it can't be a parabola. All right. What about the signs? One's negative, one's positive. So what is it? Hyperbola. Hyperbola. How are you? Okay. All right. Now. All right. So what we're going to do, and again, because both of these are plus 0, our center of the box is at 0, 0. Uh-oh. Wait a minute. Look at the coefficients.
They're the same.
They're the same, so this is a circle, isn't it? Okay, I didn't see that either. All right, because, so really, if I multiplied everything by 25, I'd have 25 out here.
I'm so dumb.
All right, oh, no, I take it back, Why can't we do that?
Because they're different signs, right?
Because the signs are different. For it to be a circle, the sign has to be the same. So it is a parabola. That's a weird problem. I got this off of the internet, and the program just does it randomly. Now, this is weird, but now my box is going to be 5 and 5. Right? Now, okay, even though I got confused, and I did. I got confused. What happened each time I tried to go forward? I realized that I was breaking one of the rules for what those conic sections look like. Right? Because this has a negative in it, it's got to be a hyperbola. Can't be a parabola because they're both squared, and it can't be a circle because both the coefficients are the same, but they're not both positive. Okay? So now I have a box. All right, which of these endpoints am I going to use? I'm going to use the y endpoint, so I'm going to use the top and bottom. When I draw the diagonal, when I draw this diagonal, I go like that. So how am I going to draw this? And makes sense? Now, why are we doing this? Because on the next page, you're going to have to do it. Okay. All right. So, question about that one? Now, was that tricky? Without a doubt, that was a tricky one. All right. Most of the time, you won't find a hyperbola where the box has the same length as width. Okay. So, all right. Next one. What do you see? One is squared, one is not. So what is it? Parabola. Okay, what's the center, the vertex of the parabola? All right, opposite, same. So it'll be 1, 3. So at 1, 3, that's my vertex. Which way does it open? It opens up because this is positive. Right? And the y ends up being something like this. And if you remember, negative b over 2a is the x value of the line of symmetry. And so if you were to multiply this out, negative b over 2a would have been negative 2 over 2. So the opposite of that is 2. And so 2 over 2 is 1. And so that's where that would be. X is 1. All right, next one. What do you see?
It's a hyperbola.
All right. Now again, this is tricky. All right. If I make this first problem in fraction, what does it look like? Would it look like this? Okay. Now it looks like a what? An ellipse. Why an ellipse? Both positive, and there's a plus sign in between. All right, now the minor axis is 1 and the major axis is what? 5. Okay, so we have a box that looks like this. All right, where's the center of that box? Center of that box is at opposite 1, 0. See it? All right, 1, 0 is the center of the box. And again, what would happen if this had been a minus sign? We'd have been doing the outside to make the hyperbola. Because it's plus, we draw the ellipse inside. Okay? Now, next part, which Algebra 2 people always love, or Algebra 2 teachers anyway. All right, in order to be able to get this, the first thing I have to do is complete the square after I figure out what it is. Okay, so I have an x squared, but I have a y in the first. So what is it? Parabola. Okay? Now, I have to complete this square. So the first thing I'm going to do is pull out a negative 1. Negative 1, this will be x squared minus 10x. Right? Now, what happens when I take half to 10? 5, negative 5, right? So that means I have x minus 5 quantity squared. Now I've just completed the square. The extra number in here is what? A 25? What's 25 times negative 1? Negative 25. Because I have a negative 25 that I've inserted, I have to add a plus 25 so that I don't change the equation. Now, this has to go the other side. So this equals negative y. they're both negatives? Add them. How about multiply them by -1? When I do that, that becomes positive, but this becomes negative. Now, where's the center? Opposite, same. Is that 5? -25 is the center, and it's going to open along the x-axis this way. No, I'm sorry. I'm looking at it backwards. The y is singular, so it's going to open this way.
You said the center was -25?
The center is at 5, opposite of this, -25.
What about the number that was already there, the 21?
This 21, that's right, I didn't see that. Okay. Let's do that again. Here I had a plus 25, so that makes this a plus 4. So that will be there'll be plus 4 here. No, actually it won't be, because then I'll multiply it. You know, the center is going to be at -4 instead of -25, because I didn't add the 21 together. Okay, thank you. All right? So, now, the directions just say classify. So we're going to speed this up a little bit, and we're just going to classify and not necessarily graph it. Okay? So now I think what I've got to do is move this over so we can see the rest of it. All right, and what do you see here? I see a y squared. That's easy to find. What about the x? All right, so what kind of graph is it? Parabola, okay? And it's going to open sideways. I don't know which way until I finish. Right? It's going to open sideways. So it looks like it's going to open to the positive side. All right, now, let's skip down to 12, just because I'm going to go back and forth. So let's look at 12. All right, what do you notice? X squared and y squared? Both the same, so it is a circle, all right? And the center of this circle will be this will be x plus 3, and the center of this will be x minus 1, and so using opposite, we will have -3, 1 is the center of that circle. Now the value of the radius, you're going to be adding some extra numbers, and I didn't figure out what it was, so I can't tell you, and I'm not going to take the time because we don't need it. Okay, now what happens here? What do you see? X squared, but y. So what is it? Parabola. Not hard, right? Okay, next one. All right, not a parabola. Why? Because they're both squared. Okay, what do you notice in between? There's only one conic section that has a negative in between. Hyperbola. Okay? Getting easier? Okay, what do you see here? Getting boring. One of them squared, so what's it have to be? Parabola. All right, good. Go to 16. What do you see? One is squared, so it's a parabola. Boy, now we're experts, aren't we? I did it? Yes, I did. Okay. 15. What do you see? Both squared, but one's negative, one's positive, so it's a hyperbola. Okay, very good. All right, now we go to the fun one. Okay. Now, our book is not working with focus or foci. Foci is the plural of focus, just like radii is the plural of radius.
I didn't know that.
Huh?
I didn't know that.
All right. Okay, so first of all, what do you notice about these equations here? What do you notice about this equation? Why is it a parabola?
Because one is squared.
One's squared, one's not, right? But now we have to do the math to get these things in the right place. So it looks like I'm going to take a -2 out of this, and that'll leave y, and what's half of this? After I take the 2 out, this will be positive 2. Half of positive 2 is 1, so I have this. I'm shortening that. Okay, now, the third term is a 1. 1 times negative 2 is negative 2. Because I have a negative 2 here, I'm going to have to put a negative 2 over there. Right, now, the x needs to come to the other side, so it's going to be negative x. The 1 needs to come to the other side, so that'll make this minus 3. You notice everything is negative? So I can multiply by negative 1. And now I have opposite, opposite. Because the numbers, the constants are on the same side as the equation. So my parabola is going to have a vertex at... Ah, you fell for it.
Why?
What's the x?
Oh, it's negative 3.
Negative 3, 1, right? Okay, so this is going to be at negative 3, negative 1. Now, thank you for answering that out loud. That was the thing that you've got to be careful of. So make sure when you're selecting, if this were a test problem, make sure that you selected where the x is associated with the x, not with the y. Okay? Now, because of this, the way this is set up, do you notice I've got a coefficient out here? So instead of going over 1 up 1, I go over 1 up 1 times 2. Instead of going over 2 up 4, I go over 2 up 4 times 2. Okay, so this is at negative 3, negative 1. Over 1 up 2, back 1 up 2, over 2 up 8, which will put it at 7. That becomes the graph. Okay, 2 mistakes you can make. One mistake is getting the x and the y turned around on where the vertex is. And the second thing is forgetting that because we did so many of them where this 2 was a 1, then it's over 1 up 1, over 2 up 4. All right, this one changes. All right, question? All right, good. All right, let's go to the next one. Okay, we're going fast, but I hope that this is starting to sink in and make some sense. Okay, all right, and what do you see here? Huh? All right, I see both squared, but one's negative, one's positive. So what do we have? Hyperbola. So where are we going to be? We're going to be outside the box. Okay, so first thing we got to do is get these together. All right, so I have this and this. If I take a negative 25 out, I have x squared plus 4. Right? Because 4 times 25 is 100. I got that?
Yeah.
All right, now, when I have this, I'm going to have plus y squared equals, and it says 0 here. All right, now, how do I complete this square? I need half of this, 2, right? So this is going to be x plus 2 quantity squared. Now, the number that's left is 2 times 2 is 4. 4 times negative 25 is negative 100. So therefore, I'm going to have negative 100 additional on that side. And then this y squared becomes this. Now, what happens when I divide by negative 100? This becomes x plus 2 over 2, and negative 25 divided by negative 100 will be 4. Right? Now, when I divide negative by 100 into 1, I'll get minus y squared over 100. See that? So, now this is a hyperbola that's going to use the x values. So where's the center? Opposite? Opposite. No, 0. Negative 2, 0, right? Because there's nothing added to that. So, negative 2, 0 puts it here. Now draw the box. X direction, where do you go? 2 in each direction. So I'll have a dot here and a dot here. What about up and down? 10, yep. So that puts me here and here. And now I draw the box. Should have been inside that line. Okay. Now, because the x is first, I'm going to have a line like this, another line like that for the diagonals. All right, and what dots do I use? Use the x dots. It's ugly, isn't it? Because the scale is bad. And again, these are made, this is made by a random generator. So they basically just put numbers in there and then threw up the same picture for every number. That's the reason it looks ugly. All right, question? Now, how hard is that to do? Other than completing the square, that takes some skill. But once the square is completed, graphing it you should be saying that this is pretty simple to graph. Now, it's ugly to graph, but it should be simple. Okay. All right. What's time here? 8, we're doing good. Okay. All right, let's go to number 19. All right, what do you see? 19.
Where the coefficients are the same as the top.
Coefficients are the same, so what's it going to be?
Circle.
Circle. Okay. So, all right, first thing I have to do is I've got to pull a 4 out. Oh gosh, that's not going to be good. All right, so when I pull a 4 out of this, I'm going to have x minus 5, which means that taking half of that, x minus 2.5 squared. All right, ugly. All right, what about the y? Take 4 away from the 32, factor 4 out of 32, and I'll have plus 4, and that leaves 8. Half of 8 is 4, so this is y minus 4 quantity squared equals, now I'll bring the 81 over. All right, now we've got to do some math. First one's easy. All right, 4 times 4 is 16. 16 times 4 is 64. So I've added 64 to this side, I have to add 64 there. Now, 2.5 squared is 625, 6.25. 4 times 625 is 25. This is 24 plus 1. So it's 25. So I've added 25 here, so I add 25 here. And now, when I take these together, this is 9, 89. So that makes this 8. Right? And so what happens when I divide everything by 4? I get x minus 2.5 squared plus y minus 4 squared equals 2. Now what's the radius?
4.
No.
Wait, that was...
It's the square root of 2. You have to take the, because this is r squared. So to take the square root of it, the square root of 2, which is a little bit more than 1. Okay. Now, is that going to plot easily? No, so we're going to skip the plotting on that. But what we do is we go to 2.5, right? We go 2.5, 4, and we put a dot, and then our circle is going to be a little over 1 unit in length. Okay, wasn't that fun? Not. That was ugly, wasn't it? Okay. All right, let's go to the next one. Number 20. All right, now, what do you notice right away?
We're both squared, same signs.
All right, and the coefficients are different, so what's it going to be? It's going to be ellipse because they're both the same sign too, right? They're both positive. So therefore we have an ellipse. All right, so now we're back to the same thing. We have 9, when we take 9 away, factor 9 out of 54, we get 1 left. -6. What's half of -6? So I have 9x minus 3 squared. Now, do you see what I'm trying to show you on how to do that? You're smart enough that you should be able to do that in one step, especially if that is an even number when you factor out. Okay, now let's go to the next one. We're going to take a 4 out of -8. That'll leave me -2. Half of -2? Half of -2 is -1. So that's going to be plus 4y minus 1 squared. And then I'm going to take that 59 to the other side. Okay, because we got 2 extra numbers we got to add. All right. What is 3 times 3? 9 times 9 is 81. So I've added an extra 81. All right, what about over here? 1 times 1? 2. 1 times 1? 1 times 4 is 4, so I've added an extra 4. All right, now, add those up. It looks like 144? Oh, isn't that nice? Because what's 144?
12 times 12.
All right, it's 12 times 12, but now I can divide. So, that's supposed to equal. All right, so what is 144 divided by 9? Is that 16? Yeah. All right, so when I divide everything by 144, this produces a 16, and 4 into that, I mean what? 36? I think 36. What's 144 divided by 4?
36.
36, I thought so. Okay, and now this is now a 1. Okay, so what do I plot? Where's the center? 3, 1. Opposite, opposite. Right. Okay, so the center's at 3, 1. All right. What's the length along the x-axis? 4 in each direction. Dot. 1, 2, 3, 4. And along the y? What's the length along the y? 6 in each direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and if I draw my box, and I would recommend that you draw the box every time. And so if you're used to doing that, it doesn't matter whether you have a hyperbola or an ellipse. All right, now, because we have an ellipse, what are we going to do? We're going to draw the ellipse inside. If we had a hyperbola, then we draw the diagonals and go and attack it that way. Okay, so because this is an ellipse, all right, most of these are going to be ugly because you're drawing them by hand. Well, it's pretty good. Okay. All right, question? 15 after. Can we go to 30, right?
No, 25.
25. Okay. All right, good. All right, question on that? All right, does that help? Does it make more sense now what you're doing with those conic sections? Okay. All right, now, let's see. You have several quizzes that I gave you to work, but did I collect those? I collected those. Okay, I've already collected them. Okay, I've got you 2 homework assignments. And Ruben, I don't think I gave those to you, did I? No, I got them here. Okay. All right, now, the first one, get test 24. Okay. If you look at test 24, the first 4 problems, it is relatively the same thing that we were just doing.
Oh, definitely.
Okay. Now here's what I want to caution you by. Look at problem 4 on test 24. Now, what they have done is they have used the other method that you can use instead of the box. They have used the slope. All right, but from the center dot, how far up did they go? How far up did they go? You see the 3? So what do you also do? Go down 3. All right? Now, what about to the right? How far did they go? 2. So how far do we go to the other side? 2. Right? So we would draw the box, and the line where the 3 is would be part of the outside box, but the line where the 2 is in the center of the box. So I taught you a little bit different. But the way that I taught you is easier to do than trying to use just the slope. All right, does that make sense? Okay, so if you will, on problem number 4 on the drawing, put that box in there. Because if you're at 5 and go down 3, where are you going to be? You're going to be at 2, right? So the bottom line of that box is going to be at 2, not where it is at 5. And then you're going to find that those diagonals are going to be going right through the box that you're drawing. Does that make sense? So all right, let me try to explain it because I saw a couple of crazy looks. Okay. They've got a diagonal that looks like this, and they've got this center line, and then they've got a 2 here and a 3 here.
Right.
All right, we're going to come 3 and 3, and then down 2 and down 2, and then make the box, and you're going to find that those things are going to come right through the diagonals that are already there. Okay? And what I've found over the years, it's easier to teach the box that you use with the ellipse, and use the box and just draw in the diagonals rather than use the slope of this, which is necessary but not needed. Okay, does that make sense? Okay, so everything else on the bottom of this test is old stuff. Okay, now, number 8. In order to be able to solve this, x cannot equal 2, but you have to use common denominators.
Right.
Huh?
It only goes to 7, right?
Yeah.
I'm sorry, number 5. I was looking at the last number was 8. Sorry, number 5, you've got to multiply every term by the common denominator. Number 6, before you can square it, you got to move the x to the other side, and then check your answers, because sometimes when you square, you introduce a false answer. All right, and then number 7, in order to simplify, you have to multiply by the conjugate. So you're going to multiply by square root of 18 minus square root of 7, and then those square roots will cancel for the denominator. Okay. Now, the other test, very similar, only it's more apparent to what we're doing. So those two quizzes are part of your homework. That's the last grades for this marking period. Okay, those are the last grades. Okay, thank you for paying attention. We went hard. I hope that you got some good information out of the practice, and that's going to do you very well in the future. Okay?
Thank you.
Good job. Thank you.